Thank you so much for joining us. And today we're going to discuss our residential distribution system and its needs for the future. I'm Alexis Doyle. I'm a consultant here at SaskPower in the stakeholder relations team. Now, before we begin, I'd like to take a moment to acknowledge that SaskPower's work reaches the ancestral lands of many nations. This includes the nations on Treaty 2, 4, 5, 6, 7, 8, and 10 territories, as well as the Dakota and Métis nations. As a Crown utility, we reaffirm our relationship with the peoples of these lands and our shared determination, to preserve the lands for generations to come. So SaskPower is in the process of developing a long-term supply plan. The future supply plan is essentially a roadmap to ensure SaskPower can deliver reliable, sustainable, and cost-effective power to 2050. A big part of that process has been engaging with customers. This has been an ongoing conversation going back to the fall of 2022. That process began with understanding the information customers were looking for and how they wanted to participate. In fact, this whole Power Talk series was one of the first actions taken following stage 1. In stage 2, we explored more about customer values and priorities. In stage 3, everything that we had heard to that point fed into the development of 4 different scenarios. We used those scenarios as the basis to have some conversations about what the future might look like. Most recently, stage 4 was about reviewing that draft supply plan, and the feedback process for that period is wrapping up. It wrapped up earlier this month, and the feedback is currently in review. So this is a quick snapshot of some of the participation numbers so far. On the slide, you'll see how many attended events, whether that was in person or online, how our newsletter subscribers have grown over time, and of course, the number of completed surveys. Now, at this point, over just 61,000 surveys have been completed, 679 in online workshops and 288 in in-person sessions like the one you see in this photo. And if you don't include the current Power Talk series, we've had 1,869 attend our past Power Talks. To get a sense of who has attended one of the many Power Talks in the past, we're just going to throw up a quick poll here, asking if you've joined before today. So you should see that pop up on your screen. If you're using a mobile device, that may not be the case, but looks like many of you are responding here. I think it's probably okay to close that off and share the polls. Okay, so we've got about 2/3 of you saying that you have been to another Power Talk in the past. So that's great. Thank you for coming back. And many of you here are many of you are here for the first time. So through this work, we have had many conversations about the future of our power system, and most have been mainly focused on that power supply piece. Today, we're going to shift the conversation to our distribution system, which is responsible for moving power to our customers. We are facing major changes in the distribution grid in urban centers, and the changes are driven by the emergence of smart technology, adoption of electric vehicles, a move toward electric heating, and even changing customer expectations and needs. We've invited you here today to understand how the grid will evolve with these new technologies and what challenges or opportunities come along with these anticipated changes, and even how our relationship with customers needs to shift. So for today's webinar, just quickly, I want to go through a few housekeeping pieces. At the bottom of your screen, you're going to see that black banner that includes a chat button. Please use the chat if you're experiencing technical issues, and one of our team members will do their best to assist you. But you'll also see a Q&A box at the bottom. And this is where you can add your questions for our panelists. So we'll be the only ones who can see it, those hosting the event. And we'll be taking questions at a couple of points during the webinar. I'll be watching those questions and posing those to our panelists. But just keep in mind that I'll be looking for questions that are relevant and related to the material we are presenting here today. So if you've got questions, say about cost of power or the environmental impacts of different supply options, I encourage you to check out the recordings of our previous Power Talks, which are available at saspower.com. Now, finally, so that you are aware, we are recording today's event, and it will be posted for those who couldn't make it, or if you want to rewatch and share the session with others. Okay, so let's meet our panelists, starting with Nathan Hoffert, who is the manager with SaskPower's Customer Solutions team. Glad you can make it today, Nathan. Thank you for joining us.
Hi, Alexis. Hi, everyone.
Perfect. And we also have Corey Golowitz, who is the project manager for SaskPower's grid modernization project. Welcome, Corey.
Thanks, Alexis. Happy to be here.
So why don't we start with a piece of trivia? And we're going to ask folks listening in approximately how many distribution customers does SaskPower provide service to? Is it 750,000, 550,000, or 350,000? So again, that question would have popped up on your screen. So we'll let you take a moment to maybe guess or have an educated guess here. Okay, let's close out that poll and share the results. Okay, so many or most of you thought that it was 750,000, and and many more, and a few less rather, said 550,000, which is the correct answer. So we have approximately 550,000 distribution customers, and to serve them, we have 142,000 kilometers of distribution lines. That's a lot of line, and that's enough to circle the Earth 3.5 times. So given all of that infrastructure, let's start the conversation. And I'm going to start with you, Corey, to maybe give us a sense of how the supply plan that we've been talking about throughout this engagement process, how does that affect the distribution system?
Yeah, thanks, Alexis. The distribution system and the supply plan, they're related, but they're fairly different in their nature and their purpose. The supply plan is really about that single value, entire amount of power needed for the whole province, hour by hour. Whereas the distribution system considers, the individual needs of each house, each business, and then the local area service transformer. So many points versus more with the supply plants, more or less one point or one number. So here's an example. In your neighborhood, SaskPower has a service cable that runs from its service transformer to your house. And that'd be the same situation for each of your maybe 15 or 20 neighbors in your area on that same transformer. So in the future, if you all decided to charge EVs at the same time or turn on electric heat or just really ramp up your electrical usage, the local distribution system assets would likely overload. So you might see low voltage or you might experience an outage in your local area. However, at the same time, the total supply of power or the supply plan might be fine. We have enough power to serve the residents, but our local area infrastructure wasn't adequate. So the distribution system works essentially the same as your house. If you overload a circuit in your house, a breaker is going to trip. On the distribution system, if the existing transformer serving you and your 15 or 20 neighbors is overloaded, it trips. Same thing, just on a larger scale. So, and as a result of the future supply 2030 and beyond engagement process, we're going to really be increasing the coordination between our supply plan, transmission plan, and our distribution planning.
Okay. That's a good start and an overview. So Nathan, I might go to you next just to let us know about what's driving the need for the change to the distribution system.
Thanks, Alexis. It really, things like climate change globally have driven the awareness for new and clean technologies. And so you may have heard, the idea that if we can develop a clean electricity system and then convert things from fossil fuels to electricity, that could help mitigate the impacts. Now, the distribution system wasn't built for today's technologies, nor that level of electrification. And so that's a challenge for SaskPower. Electric vehicles, electric heating, distributed generation. These are, three examples of new technologies and new ways that customers are thinking about using electricity that's going to change the way that our system needs to operate. And as I mentioned, as our customers sort of evolve the way they're using electricity and the devices and the technologies they expect the distribution system to be able to accommodate, so too must we adapt and change, the design and the way that we build and plan and operate our distribution system so that we can continue to serve customers in a safe, reliable, affordable way.
Right, lots of changes ahead. And so why, maybe just go into a little bit more detail, and maybe I'll ask Corey to do this, around why the grid can't handle these changes that we're anticipating.
Right, right. So the power grid was mostly built, or the distribution system, in the 1950s and 60s. And the new technologies of today's world we live in obviously weren't a consideration back then. So the original system was built when electricity usage and electricity end uses were a lot simpler. So our current power systems, it's a one-way system, it's a manual system, and we have a very low visibility on our system since we don't remotely monitor it. So we don't see outages, load flow along the lines. We don't see customer generation, and we can't see when equipment's starting to malfunction or fail. So this worked fine for the last 90 years, but going forward, it's not going to work. We need to get to a place where we have a two-way smart digital system that gives us complete system remote visibility, where we can see everything in real time. And when we have this, we'll see everything we need to see. We can start to be proactive. We can avoid issues. We can manage the system more cost effectively, and then we can, improve the reliability and power quality for everybody. So going forward, our system's going to have to be able to deal with, intermittent renewable generation, electric vehicle charging, electric heating, and much more variable flow of electricity. So modernizing the grid is a must.
Okay, so thinking about all those changes, new technologies, how are we getting ready for the shift?
Right. So how are we modernizing the grid? Yeah, we're installing hundreds of thousands of smart meters, smart devices on all parts of the provincial system. We're basically making every point on the system remotely visible so that we can monitor and control it in real time. So, in a few years, we'll know in advance if equipment's starting to fail and fix it before we have an outage. We'll know where on the system there's distributed generation or electric vehicle charging, and if the system is stable or not with that new technology. We'll know if we have extra capacity or tight capacity on every point on the system, and we'll know if we can handle the demand or not. So we'll be able to assess whether or not our wires and transformers are big enough to handle everything that's going on. And so, for example, when a customer buys an electric vehicle and most people install what's called a level 2 charger. Actually, it's probably half and half, but a faster charger in your garage so you can charge faster. At first, that customer has to ensure that they have a large enough service, because they'll probably have to handle twice as much demand at their home when that charger's running. At the same time, we need to make sure that our transformer and our cable servicing your house is adequate. And we must prepare this way for every house and every business on the system, of which there are a little over 550,000. So, the load growth associated with electrification is such a large step change that we know we can't cost effectively build our way out of it. So we're going to need a smart digital grid so that we can see where, when, and how fast energy is being consumed. We'll also be working very closely with our customers in real time, as they're going to become an integral part of planning and operating the future grid.
Right, they're going to play a key role in that piece. Speaking of customers, we actually had a clarification question from our audience. We're going to take some more questions right now because we have a break to do so. But earlier, Corey, you mentioned the concept of our system being one way. What did you mean by that? If you could just maybe clarify for folks who are listening in.
Right. Thank you. So, in the past 90 years, until recently, there was really no customer self-generation where customers could generate on their site and push energy back into the grid. One-way system means the generation is centralized, the large coal plants, large natural gas plants, hydro, and then the energy is pushed one way to the consumer, and that's it. Now we're going to see two-way energy flows, people pushing back into the grid, all kinds of different variations of that. And second, the communications. we could only see protection. We only saw the system in one light. We're now going to push communications back and forth. In the future, we'll have communications from our customer back to us and us to our customer, depending how things roll out. So it's going to be a significant change for us and a significant change for our customer base.
Okay, perfect. Thank you for
Hope
the
I answered that.
explanation. Yeah, I think you did. I don't see any other questions coming in just yet, or at least covering off what we've discussed to date. So let's keep the conversation going. I want to take a moment to just talk about how SaskPower is going to handle that influx of electric vehicles. Nathan, I feel like this might be something you can speak to.
Sure. So we've started sort of years ago, we started by gathering data. And so we've collected charging data from real Saskatchewan EV drivers and also worked with professors at the University of Regina to then model the potential grid impacts using that real Saskatchewan charging data. And one of the things that we found is that most EV drivers charge at the same time, weekday evenings, which is the same time customers already put the greatest demand on the grid. So that's a challenge. However, now our distribution system planners have the info that they need to start making better planning decisions and decisions about the system. And our solutions developers have the information they need to start developing customer programs and services that can help. When I think about customer programs and services, we're looking at developing new programs and services that are going to enable and motivate customers to shift electricity consumption off peak, if you will. As Corey mentioned, building bigger infrastructure to just accommodate the increased loads and the loads all sort of happening at the same time isn't really an option. And so we're going to have to work together with our customers to come up with ways that we can manage the peak load impacts of an electrified future to continue to ensure that the power system remains stable and reliable.
I think this might be a good time to define our terms again. Peak power usage. What do we mean by that? Why is it an issue? Corey, not to give you another chance, Nathan, but I'll ask Corey to give an idea of what that means here.
Sure. So peak demand is the rate at which power is being consumed in the moment. So for example, if you turned on every electrical device and appliance in your home at the same time, that would establish your peak demand, right? So it's like driving the 40 miles from Regina to Moose Jaw, and you're driving 110 kilometers an hour, but you pass one car, and at that moment you speed up to 125 kilometers an hour just for 30 seconds to do that. Over that whole duration, your peak speed is 125 kilometers an hour, even though you only did it for 30 seconds out of a 40-minute trip, right? So it's that same thing on our equipment on the system. When do all of those customers that are served off of that piece of equipment, when does their cumulative energy usage peak? And that's how we have to size our equipment. So we have about 180 to 190,000 service transformers and 3,500 line circuits that we're monitoring or have to monitor in real time, and we have to watch that peak demand. So the moment of peak demand is that single driver for how big we have to build each and every piece of equipment on our system: cables, poles, transformers.
Okay, super. Thank you. So maybe just thinking back about home, or about the new technologies and the adoption of electrification, thinking about home heating, what's going to happen there for Saskatchewan and SaskPower? Nathan, back to you.
The short answer is we're not sure, but we're monitoring it closely. And so, most people on the call know most of Saskatchewan heats its homes and businesses using natural gas. And if we converted that from natural gas to electricity, it would have impacts on the electricity grid even greater than the EV charging impacts Corey spoke about earlier. Around the world and in parts of Canada, there's excitement about heat pump technology as a potential solution to transition away from fossil fuels and using less electricity than, say, traditional electric resistance heating. The challenge in Saskatchewan is that we know that this technology isn't a great solution in our cold climate because it doesn't perform very well below -20. And with many days and weeks colder than -20 in Saskatchewan, we know that customers are going to need some other heating source to supplement their air source heat pump. And if that happens to be electric resistance heating, then that's a big challenge for the grid and also a customer's wallet. Electric resistance heating, if that's what the supplemental source is for when it's coldest, that costs about 4 or 5 times as much as heating with natural gas. So it's expensive for customers as well. Again, though, it's too early to draw any conclusions, but we're watching this really closely. We're collaborating with industry experts to try to come up with some solutions for Saskatchewan. And I'll plug that there's some great info on saskpower.com that compares the lifetime greenhouse gas emissions reductions and annual heating costs of different fuel sources. And we collaborated with Sask Energy on that. And includes, a natural gas furnace. It includes air source heat pumps. It includes some different fuels like electric and diesel, I think, as well.
Yeah, that's a great source actually. I wonder if maybe we can add that to the chat to give it at people's fingertips here on the back end. So what load management and what is load management first off, and how could it work? Essentially, what is SaskPower going to be doing for urban residential customers?
So I mentioned working more closely with customers, and load management, it's just an energy management strategy used to reduce energy demand on the customer or the load side, rather than exclusively just trying to manage those peaks by generating more or less electricity, more or less power on the supply side. And because we expect things like electric vehicle charging to become more common in urban residential areas first, our immediate focus is looking at peak load management solutions in urban residential areas. But what we're really talking about are non-infrastructure solutions. So things like active load management programs and passive load management programs, different incentives, different pricing and rate options for customers, policies and fees, and of course, customer engagement and education initiatives, all focused on empowering and enabling customers and SaskPower to more effectively manage those peak loads on the distribution system. So working with our customers to flatten that load is a big part of this solution, because it's much more cost effective and doable than building bigger infrastructure.
Right. Thinking about all of the variety of programs that exist, I wonder if we can just talk about this problem, because it's not unique to Saskatchewan. And so what are some other places doing?
Yeah, I can speak to that one, Alexis. So, as Nathan can as well, every utility in every jurisdiction has to address electrification, new smart technology, distributed generation. So, the difference is really our timing, the pace of change, the local resources available to the utility, whether that be hydro, coal, gas. And then there's always the local public, or public social and political views, right? But one thing that's truly universal is grid modernization. You've got to get to a smart grid. So, but some are implementing smart meters first. Some have gone to installing their central, IT technology systems. Some are installing smart field devices first, or dealing with non-wire solutions like microgrids. So, I guess to answer your question more directly, just a few examples, and these are higher level. But for instance, BC and Quebec, BC Hydro, Quebec Hydro, they're both hydro based as per their name. EV adoptions have been much larger and sooner than us. So lucky for them, they have the cheap, abundant hydro. So they have ample resources to develop many programs and services around EV charging, energy storage, and so they're viewed as leaders. Some of the maritime provinces, they're on a similar path to us. They're developing smart grid and running pilots to see how they can integrate electric vehicles and distributed generation without really hurting the grid, I'll say. NMAX and EPCOR, they serve Calgary and Edmonton. They're high density, million person cities, so high density populations. So they're focused on, load balancing, EV charging, and rooftop solar, right? That's some of their things they're dealing with. So ATCO, then, they're a rural Alberta service provider, and they're really working on microgrids for remote northern communities. And Manitoba Hydro, they're a little behind, being that they've been really focused on building large transmission and selling their hydro south into the U.S. market. So that's been their aim. And as most people have maybe heard or read, California is looking at microgrids to address wildfire risk. Hawaii is all diesel, so they're trying to drive solar. And actually, you might not know this, Texas is racing to get ahead of server farms that are feeding artificial intelligence, and that's outpacing EV charging in their jurisdiction. So everybody has their challenge. For us, we serve 650,000 square kilometers we call Saskatchewan, and we have a plan that includes some of all of these concepts. And, we have to do different things in urban, rural, and the far north. And we've set timelines that align when we think these various challenges are going to show up in Saskatchewan. So,
I love that overview. It's like we did a little tour of Canada and a bit of North America, but clearly you're tuned into what other jurisdictions are up to. That's great. So I know that there are probably lots listening in, wondering about these changes, and we've talked about the fact that the customer will play a big role in that. What are some ways people can help with this change?
At a really basic level, residential customers who become more aware of their electricity use can just start to simply consider their impacts on the power grid. You can help SAS Power by being mindful of when you use electricity and reducing electricity during peak periods. So winter evenings and summer in the late afternoon to early evening. That's the time when most customers are putting the biggest demand on the system. So simply being aware of that and doing whatever you can to avoid using electricity during those times is helpful. Additionally, though, a focus on energy efficiency and improving your building envelope is another way that you can help. Lowering your consumption for power as a first step will make it a lot easier on your wallet for when you think about adding electric vehicle charging, for example, because you've already created a little extra capacity on your existing assets and infrastructure, and you've also reduced your costs in advance. Energy efficiency and conservation help SAS Power manage our peak loads. The benefit is it also helps customers reduce their power bills. And so, electricity that is never used, it never has to be generated, transmitted, or distributed. And so that's the lowest cost and cleanest form of emissions reduction. SAS Power is committed to making it easier for customers to help and contribute. And so while we're at this, we'll develop solutions that make it easier and beneficial for you to make changes to your electricity use so that, again, you're both empowered and motivated to take action to contribute.
Okay, conservation and efficiency was kind of my two takeaways from that detailed response, but excellent. Okay, so thinking about customer generation, where does that make sense in an urban setting?
Customer generation won't solve these distribution system challenges in our urban centers, right? We're talking about assets and infrastructure that with capacity limitations, and these issues aren't related to a lack of electricity supply. So the rooftop solar, for example, doesn't necessarily solve what we're facing on the distribution system. Load management, energy efficiency, and conservation, these are more impactful and lower cost solutions for customers. And so that's where SAS Power would direct customers to focus if they're keen to support. Now, having said that, battery energy storage systems are an interesting technology that's not explicitly, generation. But if paired with solar, for example, that could provide greater value to the grid than solar generation alone. And as we look at future opportunities and challenges on the urban residential distribution system, we'll invite customer input, and we expect to work together more closely to continue to work through some of these solutions.
Jolene, I think we might have lost Alexis here. Or
Well, then while we're waiting, oh no,
yep,
you're there.
sorry, back. A little bit of technical difficulty there. Thanks, Nathan. Apologies on that. So this would actually be a great time to maybe add that next week our Power Talks will be focusing on that microgrid piece. And so if you're interested in talking a little bit more or learning a little bit more about this piece of the equation, you can register at saspower.com/powertalks there. But Nathan, I cut you off. You were going to say something.
No, I was gonna plug the Power Talks.
Oh, great. Okay. Thanks. All right. And there it is there. It's on same time, same day of the week next week on the 5th. So okay. So I know that last week at our previous Power Talk, Monica and Fern walked through SAS Power's affordability programs. So can you provide a quick recap of what kind of efficiency programs we offer here? And Nathan, I feel like given your role, you'd probably be able to give us a good overview here.
Absolutely. I'll give you kind of a rapid fire here of what we've currently got to offer. So in the residential space, we offer an energy assistance program for income qualified customers. We also offer home efficiency retrofit rebates in partnership with Sask Energy. We've also got a Northern First Nations home retrofit program that's for electrically heated First Nations communities in Northern Saskatchewan. And currently in stores, in retailers kind of across Saskatchewan, energy efficiency discounts. So you can get discounts in store on energy efficient products. And for small, medium, and large commercial customers, the Commercial Energy Optimization Program, it offers coaching, technical support, as well as incentives for energy efficiency related projects. Helping customers reduce their electricity consumption and becoming more energy efficient, it helps SaskPower better manage its system, as I mentioned. The added benefit is that it also allows SaskPower to support customers who might be more greatly impacted as we navigate through the clean energy transition. SaskPower.com/efficiency has information on all the programs that I quickly mentioned, as well as some great information and tips to help lower your energy use. There's also for residential and business customers, there's 2 separate self-service audit tools that'll provide you with custom recommendations of ways that you can lower your energy consumption and lower your power bills. And through our engagements on SaskPower's future supply plan, energy efficiency programs and technologies that help customers reduce their bills was the only unanimously supported aspect kind of discussed. And because of that, we're planning to publish energy efficiency targets as part of our long-term supply plan, and we'll share those results regularly.
Just flipped up the slides there. Apologies on that front. Just want to make sure, oh, I just lost everything. A few technical difficulties here. I don't think I'm sharing my screen any longer, am I?
No.
Okay.
I don't think so, Alexis. Yeah.
Okay. Just give me one quick minute and I'll get back to this. Maybe in the meantime, when we think about all these changes and the costs associated, what does that really mean for our power bills? I'm sure lots are wondering whether that's going to increase. And Corey, maybe I'll hand it to you while I get the screen back up and sharing.
Sure. The cost very much depends on how and when people are going to use power in the future. That's a really big variable. So if we can do a good job informing people of such as this event, of the impact of when they use power and when they charge their EVs, those sorts of things, people can make the personal decision to help, and the overall cost to upsize the distribution system will be dramatically less as more and more people work to help reduce that peak. So, our plan includes a combination of peak load management, as Nathan talked about, and infrastructure upsizing. We do have to rebuild infrastructure. It's aging, and some of it has to be upsized. But we're going to have a combination of that. So the cost to do this is expected to be much lower than trying to just build our way out of it. So it's clear that since much of the energy that we're using as a society today is transferring from fossil fuels like natural gas and heating or gasoline for vehicles onto the electricity system, we have to build bigger to some extent to serve the rising demand for power. So this will put upward pressure on rates. But as we develop, the smart grid and real-time capabilities, we can better manage the grid and we can better interact with our customers and their smart devices, which will help us both realize efficiencies as Nathan talked about. That'll certainly help. So as a province, really, SaskPower, our government, industry, and the people of Saskatchewan, we're going to have to work collaboratively to develop that modern grid and leverage every energy asset we have in order to be successful and keep rate pressure down.
So there are some questions that we received in the chat that I think are related here. And so let's just take the next few minutes to, actually we have lots of time to get to questions. But one of those questions was focusing on that billing piece and what it will look like in the future, and tying back to some of the programs, Nathan, that you talked about as well. What is the opportunity around maybe time of use programs, incentives, industrial demand? Like what, can we speak a little bit more to those opportunities?
Yeah, certainly. And I would say broadly, we're considering everything. And so when I mentioned earlier about thinking about different incentives and different pricing models and different rates and fees and things like that, those are the kind of things we have in mind. At present, we bill most customers sort of a flat cost per kilowatt hour. And we're looking at how we could, how we could offer alternative options that would send more appropriate price signals to customers, and that would encourage the kind of behavior that would both reward and sort of discourage negative impacts, reward the positive impacts to the grid and discourage the negative ones. So what can we do to try to shift customer behavior? What can we try to do to encourage the kind of behaviors and actions that would benefit the grid? And so yeah, those are examples of all sorts of things that we're thinking about and we're looking at.
Okay, and there's someone who's listening in who has a better sense, I think, around um, residential versus industry demand charges on billing. So do we see, so I understand that there is that charge for industrial users on their bill right now to basically help handle that peak load management piece. So given all the programs that Nathan, you said that we're exploring, do you think that there's a future where residential demand charges will show up on our bills?
I don't know. Like I said, we're looking at all these different considerations, and we'll work with customers and with SAS Power to try to figure out what works. What do we think works? The best way to kind of solve these distribution system challenges. But in the same breath, I'll also say what works for customers, so that we can sort of mutually solve this together.
Okay. Now, I think you mentioned some opportunities around like building upgrades. So question from someone is around incentivizing energy retrofits. Is that part of the plan? Do we have some support or tools available today to help people navigate that? Because if our buildings require much less energy to keep warm in, say, the winter, or cool in the summer through these low-tech solutions, insulation or air sealing is what's being suggested here. What kind of incentives exist for those particular easy, low-hanging fruit pieces that someone might be able to do in their home?
Yeah, absolutely. I mentioned the programs currently available, and we expect to continue to, investigate and roll out new and different programs that are going to support peak load management. So again, I'll plug saspower.com/efficiency to go see the full list of programs. I will mention there's a home efficiency retrofit rebate program that's available. I mentioned the commercial energy optimization program, in-store discounts through the energy efficiency discounts program that's in stores right now. So there's things available to customers if they're looking to improve their energy efficiency.
Okay, so thinking back to, thanks for that, for the reminder on what exists today for the retrofit piece. Thinking back to the changes in technology and adoption of those technologies, so in particular, electric vehicles or home heating. Someone's interested in understanding what are the expectations might be for moving to electric heat, as well as electric cars in this province. And then if that's the case, do you think that moving to a 200 amp standard household service is necessary? Corey, I don't know if that's for you.
Yeah, I can maybe speak to that one. For a two-part question, if I heard it right, Alexis. But in terms of expectations around EVs and electric heating, we as the provincial electric utility, we serve the load that the people of Saskatchewan bring to us, and we have an obligation to serve, and that's our business. So I'll say we're somewhat agnostic on that, and we're really weighing out what are the benefits of electric vehicles to SAS Power and to the people of Saskatchewan, electric heating. And some of those trade-offs are the impact on the grid versus the CO2 or GHG reduction value. So, but really, first and foremost, we're here to serve the load. So I would almost say, we don't have a mandate to drive those one way or the other. We want to make sure we can serve customers' needs. In terms of a service size, I think what we would suggest, and this only works up to a limit, is increasing the capacity of your service panel from, say, 100 amp to 200 amps. I guess first you'd have to spend the money on your side to do that. It's thousands of dollars to upgrade the system or the service size. And then we may have to do upgrades on our side as well. And we can do that. But I think what we suggest first is something like inventory your energy usage. Think about how you're using electricity And can you work with the capacity you have through some, as Nathan talked, when are you going to use your electricity? Can you move some loads to overnight or off peak? Because if you can avoid a capacity increase, that saves you money. It saves impact on the grid, and it saves us having to build bigger infrastructure.
Okay. It's possible you've kind of answered this question indirectly, but someone's thinking about EV chargers at home and specifically level 1 chargers, which would be a 110 volt. Would a level 1 charger play a role at all in maybe reducing the demand on the grid, or I don't know if
Yeah,
you understand
absolutely.
that,
And
or
maybe
yep.
maybe I'll ask Nathan to weigh in as well from his side of things. But from the grid side, a level 1 charger draws a much smaller demand. It's about 1.3 kilowatts versus a level 2 can be anywhere from 7 to 10 to 20 kilowatts. It's just unbelievable size step up for level 2. So level 1 is much more manageable for the grid. And I think that's something we'd love to see people spread their consumption over time rather than taking a huge amount for a few hours. Nathan, anything you'd like to add?
No, other than just that's if a customer can do that and that works for them, that's fantastic. I think,
Right.
for some customers, for maybe many customers who are considering an EV, being able to charge quickly is sort of an important piece. And so, that's the reason why we're trying to figure out what other kind of solutions can we come up with that work for customers and also again benefit SaskPower in the distribution system.
Okay. So I know we talked about customer self-generation, we touched on it a little bit, but if we just think about the broader implication to the distribution system, maybe can you just highlight again what the implications are for customer self-generation as it relates to the overall distribution system? Positive, negative?
Well, Corey, you can chime in. I'll say again, the best way for our customers to support our transition to net zero is through energy efficiency and conservation and load management, as we've been talking about here, and that's why this is where we're focusing our efforts. I'll also mention, these options are also more accessible to more customers compared to some of the upfront costs associated with self-generation, which can be a barrier for many customers who are looking at that as an option.
Yeah, and I'll add, we're trying to determine where and when or distributed generation is of value or when it's not of value to the grid. But I think this would be the focus we're taking is where can any source of energy really result in a demand or a peak demand reduction? So can you help reduce the peak demand on the system? That has significant value. Energy into the system has value, but less value. So, when we're not at our system peak, our generators can handle the load. They just push out a little more energy and they handle the load. It's making sure we don't set a new peak that we have to build the next generator and we have to build all the lines bigger, the transformers bigger. So, any generation that's where our focus would be is can it help reduce that peak over supper time and in the early evening? And I think that's where we're gonna work to try to figure out the value to us. So that's a thought, that's a sense or something to think about.
Thinking about the history of customer self-generation and some of the incentives we were talking about earlier, are we looking at other programs for individual homes, say solar panel heating is what this person is interested in. So are there any opportunities for incentivizing that kind of solution that this individual is looking at?
Sorry, say the technology again.
It is solar panel heating, home solar panel heating.
I may sort of be misinterpreting what the technology is or how it works, but I mentioned when we were talking about home heating and business heating in Saskatchewan, I think there's still so much uncertainty. We don't know what the future of home heating looks like in Saskatchewan based on
Mhm.
based on a ton of factors. I think there's so many decisions still to be made that it's a situation that we continue to monitor and try and do our best to plan for, knowing that there's still a lot to be worked out.
Yeah.
When we're,
And
yeah,
I'll just say, if
go
I
ahead.
can, Alexis, quickly, from the grid perspective, and working with our customers, the more electric heating that comes onto the system, the more pressure on having to build it bigger. So from the other end, anything that can take electric heating load off the system is probably a good thing. So if something like, solar based heating, or uh, any other fuel other than electric resistive heating, it's probably something we'd want to consider. But we're kind of, as Nathan said, on that early analysis of that, to see what the impact might be and what sorts of things we would want to incent or support. So yeah, I think it's a good consideration or a good suggestion.
For those who do have who do participate in the net metering, or maybe have EV vehicles or chargers at home, um, there's a question around whether or not we're able to capture any information or data from those users. And if we do, how do we use it to maybe inform our programming and service offerings?
Well, we like when we're looking for programs and services, typically we start by, we look at what's going on in other jurisdictions. So we keep close tabs on, the United States, other parts of Canada, and look at what options are being offered there and think about what might work in Saskatchewan, what might help us solve a challenge that we're dealing with. And the second piece, the most important piece, is then we look at our customer data and our feedback from customers, from sessions like this, from customer research to say, is this something our customers would want? Is this something our customers would find value? And when we find something that our customers would value and something that solves a SAS Power issue or provides a benefit to SAS Power, that's typically when we think, okay, now we've got something, and then we figure out how to build it and package it and deliver it for the Saskatchewan market.
Yeah,
Corey's in agreement.
I'm in absolute agreement. Yeah,
Okay.
I guess what I'll just add quickly, if I may, on that note, is that I'll let it go, Alex. I think we've got another question. Go ahead.
Okay, yeah. A few different questions actually on smart metering. So maybe we'll shift gears here. So when, what does smart metering really mean? And how can it inform usage patterns? And then how long does it take to see that data and how we might use it? So
Yeah.
what is smart metering? We'll start there.
Okay. Smart metering, I think, in the common definition, is an automated meter at customers' residence, where it's actually it's measuring the data and keeping tabs on the data in 15-minute increments. So it's interval data. It's collecting a lot of data that we can then bring back and we can share with the customer. And you can kind of see a graph, a load profile. Oh, it picked up when I woke up, and it went down when I went to work, and then it was up when I was at supper time. So that data in aggregate for us can help us see when are our transformers or our lines being overloaded, when are they fine, where is the energy, when are customers of this type, commercial or residential, oil field, using more energy on the grid, and how. So it's a ton of good data that we can make much better planning decisions with. The other avenue of smart meters is our own smart meters on our own devices, on our own system, in our substations, along our lines, so we can see the load flow against our other assets that don't directly serve individual customers, but they're critical to get the power to customers. So we use it to plan and optimize our system, and we can use the customer data to plan and optimize how we serve our customers cost effectively. That's component one. I forget component two.
Yeah, that's okay. Just how can we use that data to inform or
Yeah.
to better understand usage patterns and whatnot? But just maybe before you answer that, it's interesting to hear you talk about the um, the benefit of having a smart meter in terms of the opportunity to learn about usage
Mhm.
and maybe feed into Nathan the question you answered earlier around how you can help, right, around conservation and efficiencies. By having a smart meter, you can learn a little bit more about your usage as well, right, as an individual. So yeah, how do we use that data, Corey?
Sure. I'll talk a bit about how we use it, and yeah, Nathan can probably speak much more elaborately to how we can develop customer value directly. So we use that data, as I said, we're building analytical tools now. We're gathering that data, and like I say, we can now aggregate that data on an individual transformer, or up to an individual line, or right up to a substation, and then we can see 15 minutes by 15 minutes. So let's say hour by hour for every hour of the year, what the loading is on that asset, and we can see the asset has X capacity and the load is where in relation to that capacity. So it gives us much more precision in where and when to invest money. So we're not, making ill-informed decisions. We're making very informed decisions, so we can better deploy our capital, and we can better serve our customer base. Because when Nathan and I talk about it helps Sask Power, what we're really saying is it helps rate base or every payer in Saskatchewan keep their rates low, because any costs we take on really transfer over to the rate base. So we're working hard to do that in all aspects, and that's what that data can really do for us. Lastly, we get remote meter reads, so it's much more efficient and less costly, so that helps keep rates down as well. Nathan, anything from the customer end?
I will add, the most basic is accurate billing. You always know exactly how much electricity you've used. You're always getting billed for the exact amount. There's no estimates, there's no variability there. But even further than that, Corey was talking about how on our operations and planning side, we can use that data to plan better and figure out, understand more about how electricity has been used. That goes on the customer side too. From the customer solution side, that gives us the opportunity to provide custom personalized insights into your electricity use. So, if we have smart meters and we have a load profile and electric use that's specific to your house or your business, we can leverage analytic tools and different software pieces that can read that data and say, this is where you can save money. This is where your load profile differs from, say, the masses or what we would expect from the norm. So there's much more opportunity to provide real prescriptive recommendations and solutions for customers on a real custom basis.
Yeah, interesting. It's almost like a technical advisor at your fingertips on that front, hey? Just curious, do either of you know offhand what percentage of residential and commercial customers have smart meters right now?
I do. It sounds like a planted question, Alexis. I do. I just looked at that this morning. 13% of our residential customers have smart meters. We're deploying about 500,000, 480,000. So we've got about 41,000 out there. And of our commercial industrial customers connected to the distribution system, we have 91%. That's about 48,000 of 56,000. So we really good for sample data, really good for learning what value we can bring to customers and how we can use that data to improve the system and keep rates low.
Okay. I had a pretty practical question, actually, just thinking about this big transformation that's happening, and maybe the job opportunities associated with it, because it sounds like it's going to be a lot of work. What kind of job opportunities do you think there could come with this change, and maybe the skills that would someone might look to develop further if they're interested in playing a role as an employee?
Nathan, I'll take it. I'll talk from
Go ahead.
From the grid side, and that's something we're learning about and we're exploring. I've had a chance to interact with utilities around North America recently on that, and I'll just say, not generically, but in categories, technicians, data analysts. Really, we're taking manual equipment and we're going to digital equipment. So a lot of comms modems are going to be out there, a lot of data transfer, smart devices. So, those technologists and data analysts, just a couple I can think of that are going to be extremely valuable. And then as we look forward, good, bad, or otherwise, artificial intelligence and those sorts of things. And so a lot of, I think, technology jobs and smart equipment management or maintenance jobs would likely to grow. Nathan?
I don't think I've got anything to add.
Yeah.
Okay. Maybe perfect timing, because I'm just looking at the clock and I think that we probably should be wrapping up here with only 5 minutes left in the hour. Where am I? Sorry, guys. Okay, so let's wrap up here. I want to start by thanking both of you for your insights and knowledge and for sharing your perspectives today live with everyone who's listening in, and to everyone who connected in today to listen to the discussion and ask your great questions. As I mentioned, we have recorded this discussion with all those hiccups and all, and we'll post it online at saskpower.com/engage for those who again couldn't make it in the coming days or want to revisit any of the answers. So we would like to hear from you before you go. We just want to run a quick poll. It should take about a minute to evaluate today's experience. So you should see that pop up here. Just 3 quick questions. So make sure you scroll through to see the first one, which is whether or not you learned something new. The second around rating the quality of today's event. And then if you would attend a Power Talk in the future. So we'll keep that open just because there are the 3 questions there. And I hope you can join one of our next Power Talks events. That is next Wednesday at noon, where we're going to bring other electricity industry experts and professionals together to share their knowledge and experience specifically on microgrids. So another plug here. And if you can get details on how to register for that again at saskpower.com/powertalks. And in terms of our future power supply plan work, we've completed stage 3. To date, over 25,000 residents have provided input, which is excellent participation for industry standards. And we're going to continue to hear priorities like affordability, stability, and the environment, and the fact that all of these are really important to our residents here in the province. So go to saskpower.com/engage to ask a question, share your ideas, and sign up for our newsletter. We want to see those numbers keep ticking up to stay informed. So with that, again, thank you, and I hope you all have a wonderful rest of the day.